Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn a very powerful mathematical method called diagonalization. And then what you do is, you write all the eigenvectors together. You write the first eigenvector, the second eigenvector, the third eigenvector, and that is called augmenting, writing things together, writing the matrices together. My job as a mathematician is to convince you engineers that there is a connection between any given matrix and the diagonal matrix capital D which contains the eigenvalues. Okay, you might be asking me why? What's the use in that connection? Very simple, to find very big powers of any matrix. Imagine, suppose you want to find a to the power 100. Point number one, you have to realize a number to the power 100 is an exponential function, especially if the number is bigger than 1. If it is between minus and 1, the number will become smaller. But if the number is bigger than 1, the number will become so big that the calculation will be so difficult even for computers. Okay, that's another fact. Now imagine you're multiplying again and again and again and again 200 times, 300 times, etc. But if you know this connection, you can just multiply 1, 2, 3 matrices and get the answer. So once more, my job as a mathematician is to tell you there is a very good connection between the given matrix and a diagonal matrix which contains the eigenvalues. And in mathematics, in your exams, they will ask you verify this connection, and that is called diagonalization. And in most of the engineering courses, they will keep two methods. One is similarity transformation and another one is the normalization method, that's called the orthogonal transformation. But similarity transformation can be applied for any matrices. Okay, now I'll tell you some applications. Point number one, Google ranking of a web page. Okay, now imagine I have a website a.com and I have another website b.com. You look at the website a.com, and from experience we know that any customer which uses a.com is about to return to the same website with a probability 90%. That is according to the information I have given here. You can read that. Now inside a.com, advertisements come. Like when you watch YouTube, etc., the advertisements come, right? And sometimes those advertisements might be very interesting that you might click and move on to another website called b.com. And according to our experience or the experience from customers is there is a chance of 0.1. Now look at this. You may stay on b.com or you might go back. And that chance, the chance that you'll stay in B itself is 50%, and the chance you might go back is 50% according to this information. And this gives something called the transition matrix. And when you look for the long-term effects of such things so that they can decide the ranking of a page and how good to keep advertisements in a page, etc., they need a long time vision. They want to know what will be t to the power maybe 1000 multiplied by the initial state. And now look at this, t to the power 1000. That looks like an impossibility even with the computers. So what we do is we use this formula and we evaluate it. Not we, the computers. Okay, I'll give you one more example because many of you might be interested to invest in stocks and shares. Today, if the stock is going up, tomorrow there is a 50% chance it will still go up. There is a 30% chance it will go down and 20% chance it will stay the same. Now imagine the stocks went down, the share went down, and tomorrow there is a 40% chance it will go up, 40 it will go down, 20 it will be same. Now imagine today when I checked that there is no change. It was same like yesterday. Then there is a 25% chance it will go up, 25 it will go down, 50 it will stay same. This can be converted into a transition matrix. Can you see? The information that I told you can be converted into transition matrix. And imagine we have an initial state 100. This means I'm 100% sure initially the stock went up. Come on, that is when we invest. When you see the stock is going up, we'll feel like investing. No one is going to invest when it is down. So day one, when I observed it is going up, that is why I put initial condition 100. That's on 26 August 2025. Now I want to know, if it goes like this, what will be the long-term impact on this? So I'll calculate t to the power 100, t to the power 1000, t to the power 2000 so that I know how long should I invest. I'll be able to find the final condition after 1000 days or 2000 days. Did you get the point? And when you are trying to calculate these things, our traditional method of t times t times t times t will not be good. The better method will be the diagonalization method. In the next video, we will work out problems related to 2 by 2 matrix diagonalization